Hello, welcome. I'm Kyle Simpson, otherwise known as Getify. You can find me on Twitter at Getify, GitHub, and also at Gmail. So pretty much everywhere it matters, I'm known as Getify. You probably know me from books such as the You Don't Know JS books and my most recent book called Functional Light JavaScript. Today I'm here to talk to you about one of the lesser known topics within the asynchronous programming world, and that would be Thunks. I know that's a strange sounding word, and so we want to dig in and understand what that's about and what that does and how it helps us to understand asynchronous programming better. Where we're going to start actually is to take a step back and look at callbacks and understand something a little bit deeper about them. So I want to start by looking into what callback even means. Callback, if you really kind of trace back the roots, the idea is that your program is going to execute some stuff now and some stuff later, and when it resumes, the callback is marking the place in code where that code will resume. So if I show you this code, this is what everybody thinks of when they think of the term callback hell. They think of making a call, and then inside of the callback, when it resumes, when it gets the response back, it simply resumes the JavaScript program at that point. So line 2, it resumes the JavaScript program after the first request is completed and there's a response of v1 to give back. And so that's the idea behind a callback. And then when you have to nest these things together, a lot of people say that nesting or indentation is what we mean by callback hell. Now I'm going to take issue with that because I don't think that's really what callback hell has to do with. Actually, callback hell is fairly deep, and there are several issues that callbacks have, not all of which we will focus on today, but I do want to dig in a little bit deeper than just the nesting and indentation, because quite honestly, that's really kind of a surface level concern. We could reorganize this code in a different style of programming, and you notice I'm doing the same thing. We have the same outcome. I'm making one AJAX request and then another and then another, and I'm using the response from one to make the request for the next one. So in other words, I have a temporal dependency. The second AJAX request can't go out until after the first one is finished, and the third one then can't go out until the second one's finished. So I have a series of asynchronous steps that need to happen in succession. In other words, they can't happen concurrently at the same time because we can't make the second request until we have the response from the first request. Now, I've reorganized this code, and this could sometimes be referred to as continuation passing style. I've reorganized this code where there aren't nested callbacks. I just have one callback that's referring to another callback that's referring to another. And another way of doing this, by the way, is to pass in, and that's where continuation passing style. I've hard-coded the 1, 2, and 3 callbacks here, but we could have passed those in, and that would have ended up with the same result, that we get this sequence of steps chained together. Now you notice the reason why we have to sequence these steps together, again, is the temporal dependency. We need to make sure that 2 doesn't even start until 1 has finished. So that is also callback hell, and that doesn't suffer from the nesting or indentation problem. So I must mean something deeper when I talk about callback hell. Again, I said we can't fully get into this, but I want to just glimpse a little bit below the covers. Let's imagine what AJAX, the function, might look like. What if I implemented AJAX like this? And the whatever parts don't really matter for our purposes of discussion, but what I want you to clue in on is that I do call the callback with some response data, but what happens if I were to call it twice? The calling code is expecting that callback to only be invoked once. There's sort of an unspoken, unwritten contract between them that the callback will be called exactly one time, not too early, not too late, that sort of thing. But really, there's actually no enforcement of that contract whatsoever. And so what I'm getting at here is that you can't really trust a callback-based system. Callbacks alone have no way to ensure that they aren't called too many times, that they aren't called too early or too late. And so if this were the implementation of AJAX, not maliciously, just accidentally, if it were to call the callback twice, the calling code would misbehave and we wouldn't be able to predict why. And in fact, we couldn't really even solve that particular problem. We could sort of hack around it by setting a Boolean flag or something like that. But the truth is that we are beholden. When we wrap a piece of our code up in a callback and we hand it over to some utility like this AJAX utility, we have inverted control. On line 1 in the previous slide, we had control over the AJAX call, but line 2, when the AJAX call is being passed in as a response to the first AJAX call, we don't control that second call. It's the AJAX utility that calls it. So we have inverted that control. So that's one of the things that I mean, is that these really are not trustable in the sense that there's no verification that a callback will behave according to that unwritten, unspoken contract. But there's more to it than that, because if we stop thinking about it as a sequential series of steps and more consider it as a concurrent set of steps, meaning AJAX calls that could happen at the same time. Here's an example. I'm going to make 3 different AJAX calls, and I want them to go out concurrently, meaning I don't need to wait for the response from 1 before I make the call to 2, and vice versa also for 3. So I want to make these calls independently. And this is very common in our web applications. If you load up 2 different web components or 2 different style sheets or 2 different JavaScript files that are entirely independent of each other, then there's no reason whatsoever that you need to express any temporal dependency. But what if, in this scenario, I needed to ask for them in parallel, but I wanted to make sure that the sequencing, the responses, did have a temporal dependency? This is where callbacks really start to struggle, because there's no way for me to articulate that I want to make the calls concurrently, but I want to process the responses sequentially. I can't express with callbacks alone a temporal dependency, and that is the real problem that we face, that one of the deeper issues, I would say, of callback hell. So I can invent solutions to this problem, of course, and here's one such solution. I know this may look a little bit intimidating at first, but let me help explain what's going on. You'll notice that I'm still making my 3 AJAX calls there, starting with line 4, but the callbacks that are being provided are not the make handler callback, but rather make handler is being executed. See there on line 4, I'm actually executing the make handler. And that creates a function. If you look on line 9, it's creating and returning a new function. The purpose of that is to create a closure so that I can capture some memory. Because really fundamentally what's broken, the reason why the callbacks can't express that kind of concurrency is that I need some kind of memory for the callback to track its data over time. I'm going to have multiple callbacks that are running concurrently, and they need to remember things because one may come back too early, and I need it to remember its data until a later time when I'm ready to process it. So here I'm doing that with some closure. As a matter of fact, I'm doing that not only with the closure over the resp index variable, but also I've got a global variable in this case called responses. It's an array that will store those responses over time. So each of my inner function handlers that are created, they close over an individual value for resp index. It would be 0, 1, and 2 respectively in these 3 calls. So I'm going to remember those values, and those will be indexes into the position in the responses array. And then when AJAX for the first AJAX call calls and it invokes that handler function with a value, we know on line 10 which particular slot in the responses array to consult because we have a closure of a resp index. Now, after we've stored something in the responses array, we also need to print them out. And the idea here is we want to print them out as soon as possible, but we want to make sure they print in order. And so I've got the print responses function, which loops over the responses array in order, and it checks to see if a response has been returned. That's number 1. But also there's a second piece of state we need to track, which is whether or not a response has been printed, whether it's been console logged. So I've got both pieces of state that I'm going to track in that slot, meaning I will set an entry into the slot when I get the response, but then once I've printed it, you'll see there on line 20, I set it to false. So I need to check to make sure that not only do I have a response, because if I don't have a response, then I've got nothing else to do this loop around. If I'm on number 2 and I don't have that, even if I've got 3, I can't print it yet. So that's why I break there on line 23. But if I do have it, then I need to check to make sure it's not already been printed. So I check against false, and then I print it out. Now, zooming back out here for just a moment, I'm sure that this code can be understood if you take the time to look through it and analyze it the way that I've just done. But this is not particularly effective code. And what it's illustrating is the limitation which I think is one of the biggest issues of callback hell. That to express temporal dependencies between our callbacks, especially when we want concurrency and sequentiality in the same equation, to express that kind of temporal dependency, callbacks really fall down. They really don't offer us any particular assistance. So we have to go to a fair amount of complex detail, as I've done here, to invent some kind of solution for that. So the next time you hear somebody talk about callback hell, I want you to zoom out your thinking from just its nesting and indentation to really that there's something a lot deeper going on. It's that callbacks can't be trusted, and also they don't have a memory, so we can't really articulate those temporal dependencies in the way that we need to. That's the foundation then. Those understandings of callbacks are the foundation then for what a thunk is and what a thunk can do for us. Specifically, we're going to focus on that second part, the memory part. The trustability part we'll come back to in just a moment, but I want to zoom in on that memory question. Because if we articulate this, it's essentially that I need to be able to request something and represent that response, but I need that response to be delayed until I'm ready for it. Meaning if I make 3 requests at the same time, I might not need response number 2 yet because I'm still waiting for response number 1. So even though it may come back early, I need that response to be stored somewhere. I need that memory to happen. And I'd like a clean way of representing that instead of the artificial and confusing logic that I had to create in the previous slide. That's basically what thunks are going to give us. We're still going to be dealing with callbacks, but now we're going to organize them in such a way that they have that kind of memory, and that will allow us to express the temporal dependency that we're after. So let's take a look. What is a thunk? You'll notice here that I've reorganized the Ajax function. I no longer pass in a callback. I do pass in the URL, but I no longer pass in a callback. Instead, what's coming back from the Ajax function, I'm naming here on line 1 as thunk. Now that's kind of interesting because what is a thunk? You'll see line 3, it is a function. I said type of thunk, it's a function. And more specifically, we would then ask, well, what can we do with that function? What is the purpose? But in a broader sense, what we should ask is, I've made an Ajax request. How do I get the response? If you think about a synchronous Ajax request, if there was such a thing, which technically there is, but you definitely shouldn't be doing that. When we had a synchronous Ajax request, if we wanted the response, we could use the synchronous form of assignment, which would be the equals. For example, if Ajax here was a synchronous request, we could simply say var response equals Ajax. Equals there being the synchronous assignment. Well, we know that Ajax has got to be asynchronous, so what would be the equivalent, the asynchronous equivalent of assignment? If we can't use the equals, what would be the asynchronous equivalent? Well, we could basically say that the asynchronous equivalent of an assignment is to pass a callback in, like I'm doing here on line 5, and that callback receives the answer, it receives the assignment asynchronously. So that's what we're going to do. We're going to call that function, that thing I've named thunk, provide it a callback which receives the response, in this case the V. So that is the way for me to asynchronously assign, to essentially to unwrap the response. Now you notice that I don't have to call thunk right away. Thunk is a function that will, in essence, remember the response, and we could call it at a later time. Theoretically, we could call it multiple times, and every time we call it, if we provided a callback, it will receive that Ajax response as its first parameter. So, in other words, to define a thunk is a function that has all that it needs to do to make some sort of operation, do some sort of computation. It has everything that it needs except to receive or to unwrap the response, the computation value, you have to provide it a callback. That's essentially what an asynchronous thunk is. So how can we use that? Well, let's imagine that my Ajax utility is making this thunk, and this is how it would do it. It would create a function, and that function, of course, is going to receive the callback. There you see on line 2. And at some later time, whenever we have the data back, whatever we need to do, whenever we have the data back, we simply invoke the callback they provided, and send it the data. That's fairly straightforward, but there's something very subtle and important that I want you to understand here, which is when does the AJAX request mechanics, when does that machinery start? Well, you'll notice here that it essentially starts when we invoke the thunk, the whatever part is on line 3, rather than say between line 1 and 2. That means that we are essentially doing this in a lazy fashion. We set up a thunk that can do the AJAX request, but we don't actually make the AJAX request until we invoke the thunk. That has some profound implications on how we might use the thunk. So for example, if I were to set up a thunk for each of these 3 requests, TH1, TH2, and TH3, as you see on lines 1 through 3, the normal thought process would be that we've already made those 3 requests on each of those 3 respective lines. But as we just saw, the way we're setting up the thunk at the moment, that work has not started yet. Those requests have not gone out. Instead, we've set up a TH1 that represents the future request, and so it's not going to go make that request until line 5 we call TH1. Same thing with line 9 on TH2. It hasn't even made the request until we invoke the thunk. That's what we mean by it being lazy. Now, here I've indicated that these 3 are totally separate, that we can print out the response from 1 entirely independent of when we print out the response to 2. That's fine, but remember, we had an earlier example where we talked about what if we needed to create some coordinated concurrency here. In other words, we want to create a temporal dependence that the output of 2 needs to come only after the output of 1. How could we do that with a thunk? Well, you might think that what we could do is simply nest these thunks together. We could simply unwrap TH2 inside of the callback for TH1. Now that does accomplish sequentially putting our outputs. Our outputs will always go in the correct order, the response 1 and then the response 2 and then the response 3. But here we have a problem, because since that thunk, the way we've set it up currently, since that thunk is lazy, it means that we don't even make the request for 2 until after the request for 1 has been completed. This is a problem if you want to make those concurrently, that it's not going to be done concurrently, it's going to be done sequentially. So how could we address this problem? We can see clearly that if I nest my thunks together, setting aside any code styling issues, you may dislike the idea of nested callbacks, but setting those aside, mechanically, behaviorally, we've accomplished in a fairly straightforward way the expression of a temporal dependency. We've said that TH2 is temporally dependent on TH1. But we have that other side effect problem, which is that now we've got a sequentiality to the requests. And what the real problem is that to do this, we don't need lazy thunks. What we need are eager thunks. So let's reorganize the AJAX function to, instead of producing a lazy thunk, let's have it produce an eager thunk. Now, again, I'm hand-waving over the mechanics of how an AJAX call actually happens, but I want you to imagine that at some point in that machinery, I need to invoke an onResponse function like you see line 5, and that onResponse function is going to receive the value, it's going to receive the AJAX response, and it's going to do something rather interesting. It's going to check to see whether or not a variable fn from line 2, whether that variable has been set. And if so, it's simply going to invoke that function with the value. But if not, it's going to store the value until a later time. And so if we see, we have 3 references to function here. In other words, we have 2 callbacks. We have an onResponse callback, and we have our thunk function. These 2 are in what we would refer to as a binary race condition. In other words, we're not sure which one will run first, but we know one of them will run, and then the other one will run. And because JavaScript is single-threaded, there's no interruption. It will strictly be that one of them runs first and the other one runs later. We can take advantage of that semantic to essentially account for these 2 conditions, because we know on line 6 that the only way that the fn variable that we're closed over from line 2, the only way that variable gets set is from line 12 when we save off the callback. Similarly, we can close over the data variable in the same way. And we know on line 11 that the only way the data variable gets set is if it's been set from line 7. In other words, in that way, those if statements know whether or not the function respectively is the second one to run. If the function has been set on line 6, then we know that the onResponse function is running later. It's the second one to have run because the only way for it to have been set is if Thunk was already invoked. Vice versa, if Thunk can check for a data, if it sees that a data has been set, it knows that it must be the second one to have run because the only way data would have been set is if the onResponse had already happened. So in this way, we have normalized the race condition between these two states. In other words, what we've said is we know that the Thunk will potentially be called earlier or later, but we don't want for the calling code to worry about that. What we want is to normalize that race condition, that the Thunk may be called before we have a response or it may be called after we have a response. But either way, we want to invoke the callback with the response once we have it. So going back to that previous code, which looks exactly the same as 2 slides ago, we can now say that those Thunks are making their AJAX recalls on lines 1, 2, and 3. So they're going out concurrently like we want. But we are unwrapping them sequentially by calling line 5 th1 and then line 8 th2 and line 11 th3. Now I want you to think about th2 for just a moment. At the moment that we invoke that, we know the request has already gone out. Earlier, it went out on line 2. But at the moment we invoke th1, of course th1 is already finished. But at the moment we invoke th2, the question is, do we have a response yet or not? Now there's 2 questions. There's 2 possible scenarios. Either the second response has already come back, in which case, essentially immediately, our callback here, our 2 callback, will be invoked, and it'll be given that data. The other scenario is that th2 needs to wait for that AJAX response from the second AJAX call. It's not yet ready. But that's okay, because either way, we still unwrap the Thunk in exactly the same fashion. In other words, on line 8, we do not care whether or not the response is ready yet. It may have been ready early and then we had some closure memory to hold on to it for us, or it may not be ready and we're going to use the closure memory to hold on to our callback 2 until it is ready. What we've done is come up with a way, very simply without any libraries, to use what JavaScript gives us to express a temporal dependency and to express that memory issue that I was talking about with callbacks. We've given the callbacks via closure a way to remember their state over time. And that then allows us to express our sequential logic in a more straightforward way without making the reader, or in this case the author of this code, worry about how that works. So if I boil this down, a Thunk is a time-independent value. It is a representation of a value that we may get at a later time, but we don't want to worry about whether we have it yet or not. We want a time-independent representation of it. And the way we do that in this case is to create a function that has that memory, and we unwrap the Thunk's value by passing in a function callback that receives that value as its parameter. In that way, we can express these Thunks as representations of computations of data, whether that be AJAX calls, whether it be handlers for clicks or other sorts of DOM events, any sort of asynchronous operation, even a timer. We can represent it as a Thunk and then sequence the responses to those in a time-independent fashion. Again, setting aside your aesthetic preferences on the nesting, the Thunk does a pretty good job of expressing in code, I think certainly better than what we did before when we had to write that crazy make handler function and have a global variable and resp index closed over and all that other stuff, all that really manual logic. We've hidden all of the time handling code, if you will, inside of the definition of a Thunk. And that then makes our calling code, the business logic of our applications, a lot easier for us to understand. Now, the last thing I want to leave you with is a thought forward thinking, which is if we can represent a value in a time independent way, that may sound familiar to you because essentially that's what a promise is. So in other words, another way of saying this is that a thunk is like a promise. It just doesn't have the fancy API that a promise does. Because really what a promise does is it represents a future action, potentially a future value that results from that action. It represents that in a way which allows us to unwrap that promise. We do that by calling .then and providing a handler. So the API is different, but it allows us to unwrap that response in a time-independent fashion. And we can then sequence our chains together. We can call promise.all. We can do lots of different things with the representation of a promise. But a promise is, under the covers, essentially like one of these eager thunks that we've talked about. Now, I've glossed over one particular issue that I already brought up, which was that trustability issue. Thunks are still based on callbacks, and callbacks can still be abused. They could still be called multiple times. And if our AJAX function were to invoke our thunk multiple times or override it, we could create all sorts of haywire behavior. So they're still not trustable, but at least they have a memory so that we can express the concurrency in a more sane fashion. What a promise does is layer on top of that idea of that time independence, a promise layers on the trustability. Because promises have built into them that they will only ever invoke once, like you can't resolve a promise multiple times. The value will be immutable, that sort of thing. And so a lot of the trustability issues of callbacks are addressed with promises, where the memory aspect, the time-independent memory aspect, we've seen addressed with thunks. So that's what I've got for you today. I hope that's interesting to you. In the workshop for our event, we're going to be taking these ideas and going even further. We're going to be talking about generators and asynchronous patterns. So hopefully you've learned something a little bit more about how thunks and promises and callbacks work. I will see you at the event. Thanks a lot for being here.